will run. When you take practically, when the diode is under forward bias condition or transistor is in forward bias condition, it will act as a switch. Practically, let me explain to you. Focus and concentrate here. Let me define you what do you mean by saturation region, what do you mean by cutoff region, and what do you mean by active region. And I will give you two definitions for each of them. Two definitions for each: saturation, cutoff, and active region. And if you know this diagram, if you understand this concept, then you can understand the circuit implementation for transistor as a switch. I will complete that implementation. That is half, that is partial. So listen here, let me define what we mean by saturation region. First definition, consider region means space. This is diaph, this is certain region. Thus you are the students who are occupied there. That is certain space or area. The space of the region which is available to the left of the curve O. This is O, this is not 0, or you can write down anything, S, K, whatever. The region, this region, to the left of the curve K, A, this curve, to the left side, whatever the region is there, whatever the space is there, that region is called as saturation region. Right? In this region, I will write S. Just keep it in mind, S means saturation. In this region, emitter base junction, collector base junction, both are under forward bias. Both are under what? Which condition? Both are under forward bias. When you take a circuit implementation, this side I will have input, this is EB, this side I will have CB. At the left side I will have which junction? Emitter base junction. On the right side what you have? Collector base junction. What I am telling, in the saturation region, both the junctions are under forward bias condition. In forward bias, what will happen to the current? Current increases. So yes sir, in forward bias current will increase. Look the diagram. Emitter base means base current will increases. This is my base current. This is my base current. In this area, the particular area, IB is 0. Again it will become 20, 40, 60, 80, 100. It is increasing. And IC, collector base also forward bias. IC is 5, 10, 15, 20, 25, 30. Even it is increasing. Only in this area, you know about that. So yes, clear? As emitter base junction is forward bias, base current is increasing. As collector base junction is under forward bias, collector current also increases. Clear? Say sir. Got it? So these are the two definitions. And whatever the line K, O, whatever you say, this line is called as up to here A, K, A, that line is called as saturation line. The region is called as saturation region. In this region, both the junctions are under forward bias. Clear? Because of that, I will have a base current, I will have an increasing collector current. Both base and collector current will increase because they are in forward bias condition. Understandable? Say some. I will move to the next. What is this? I will write here C. C means what? Just keep in mind. Cutoff region. So in this space, in this region, emitter base is J1, collector base is J2, junction J2. Keep it in mind there. So emitter base junction and collector base junction both are under reverse bias. Both are under which condition? Reverse bias. Look at here, how much IB? This area. Don't focus on here. This area. This is my area. That is what is it is? What it is? Cutoff region. How much IB? IB is equal to 0. IC is equal to 0. Reverse bias. So I will have IB is equal to 0 and IC is equal to 0. Clear? Understandable? And let me give you one more definition. This area of the region below this curve, which curve? IB is equal to 0 microampere. This is line, or you can say the curve. The region below IB is equal to 0 milliampere. Whatever this region is there, that region is called as cutoff region. Two definitions I have given. In this region, both the junctions are reverse bias, or the space which is formed, which is available below IB is equal to 0 microampere or 0 ampere. This region is called as cutoff region. Understandable? Now what is the third one? Active region, or we will call it as a linear region. Now let me give you first definition. In active region, EB is under forward bias and CB is under reverse bias. EB is forward bias means I should have a base current. Phasor EB, emitter base. I have a base current in this area. I have base current, base current, base current, base current, base current. I don't have any collector current. Only focus here. Understandable? EB is forward bias, CB is reverse bias. One more definition: the central region, which is available in the graph, is center part. The central space in the central region available in this graph, that is called as active region or a linear region. Clear? Clear with the definitions? Say some. If you understand this, I can move there. How transistor act as a switch. Clear with this everything? Now let me ask you, what is the spelling of saturation? SATURATI. I will write ONS capital. In this region, transistor will be in on condition because both the junctions are under forward. Current is increasing rapidly. What is the spelling of cutoff? CUTOFF. In this area, in this region, transistor will be in off condition. Clear? On, off. Like this, transistor will act as a switch. I will explain it by using those circuit diagrams. Clear with this? I hope understand. Let me move now. Here, let me ask you. Only two choices. There are only two choices there. You don't have full choice. Which diagram is after completion? I ask you. Let me ask you. Or let me complete the diagram so that I can ask you a question. I have completed the diagram 1 and this is second. Let me ask you, which circuit diagram is under for saturation region? Which circuit diagram will tell that or which is under saturation region? Which one? Second. Others? Those two girls are correct. I will tell you. This is cutoff region. This is saturation region. Focus here. Now let me explain about these. Why have you done as cutoff? Why have you this is saturation? Now transistor will act as a switch in how many regions? Two regions. In saturation region it is in on condition. In cutoff region it is in off condition. Now let me tell you first cutoff. In cutoff region, what is the case? IB is equal to 0. IC is equal to 0. You want IB is equal to 0 means it should be grounded. Grounded means 0. Not giving any input. 0. That's why I made it as grounded. there is no current is flowing. Right? What about Vout and VCE is equal to? Why I wrote Vout means output voltage. Do you know multimeter? Have you seen multimeter? Multimeter. The yellow color one I use? No. Yes, sir. Okay. In VW lab, what we do? Just assume that I'm measuring the output by having the two wires. We connect two wires and we measure the output here. Okay. Just why I wrote VCE? This is collector terminal. This is emitter terminal. VCE. This output Vout is equal to VC is equal to how much? It is available in this graph. Focus here, I will tell you. What I am doing in the cutoff region, how much VC it is? What I am doing, I am increasing VC 1, 2, 3, 4, 5, 6, 7. Then nothing is happening to base current and collector current. My highest is 10. So your VCE will become VCC. This is VCC. This is your regulated power supply 0 to 10 volt. And when you see the circuit implementation of common emitter, and you see the what I am telling, circuit implementation of common emitter configuration like this. This side I will have input, that is emitter base. Say so no. This side I will have base, and this side I will have VCE, that is reverse voltage. Emitter base junction is always forward bias. Collector emitter voltage is reverse bias. Means you need to connect reverse potential. So what I am doing, I am increasing the potential, though I am getting IB0, IC0. Means VCE will become VCC. If you see the circuit implementation, at the right side I have VCC. The source is VCC. Understandable? VCE will become VCC. Means if you increase collector to emitter voltage up to 10 volt up to VCC. Understandable? As it is a reverse bias voltage, depletion layer increases. Just recall PN junction diode under reverse bias operation. If you increase the reverse voltage, depletion layer. What do you mean by depletion layer? You guys are looking blank. I will tell you. If I wrote P and N, what it is? What is this? PN junction diode. What is this? Junction. If I wrote a dotted line near the junction, what it is? Depletion layer. If it is under reverse bias condition, if you apply a reverse voltage, this area will increases. Means it is in off condition. Current will not flow through diode. Same thing. IB is equal to 0, IC is equal to 0. This circuit diagram, it is in off condition, cut off. Transistor will act as a open switch. Open switch means switch is in off condition. Understandable? This VCE is nothing but this is reverse voltage. We are increasing the voltage. We are increasing the reverse voltage. If you see circuit implementation, VCE will become VCC. We increase VCE 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Have you seen regulated power supply? That is the maximum 0 to 10 we will give. That is nothing but this. VCE will become VCC. Understandable? But there is no current flow in the transistor. In the cutoff region there is no current. IB is 0. IC is also 0. Clear? It is in operation. Now let me tell you this. So here in saturation region, both the junctions are forward bias. Means if it is under forward bias, what will happen to the current? Current should increase. What I am doing? The base, this is input. This is your input. Base is input. Collector is output. I am connecting base to VCC. Means I am increasing the voltage, which means I am increasing the base current. Look into the saturation diagram. This is base current, this is base current, this is base current, this is base current. I am increasing the base current. Parallelly, collector current is also increasing. Understandable? By increasing the input current, if in, for example, in general, if you give input, more input, you will get a more output. So, yes, I am increasing the base current, though there is less change in the collector current. What is base here? 20. How much collector current? 10 milliamp. See the unit, don't see the million micro. Here I am having 60, here I am having 20, 80, 25. By increasing the base current, there might be a large change in the collector current, but collector current is increasing. Why? In saturation region, both the junctions are under forward bias. That's why I connected. This is your input. Input is connected to VCC. Understandable? In the cutoff region, input is grounded. Means IB is equal to 0. If input is 0, IC is also 0. But you have this rule. Now my question is, what is Vout is equal to VCE is equal to how much? It's available in the graph. Answer is available in the graph. What is Vout? Output voltage is equal to VCE, collector to emitter voltage is equal to how much? That space, in that space, what is VCE? What is VCE? 0. In that space, what is VCE? 0. Focus here. In this space, what is my VCE? Where it is? Is it? Here it is. In the saturation, VCE is how much? 0. So your output Vout is equal to VCE is equal to 0 volt. Understandable? In cutoff region, VCE is equal to will become VCC 10 volt, maximum 10 volt. Here, look into the diagram. VCE is at 0. I am having saturation. I am having base current. I am having collector current. Both they are increased. Here, Vout is equal to VCE is equal to 0. Understandable? Say some. Got the point? Like this is off, this is on, off. That button, that switch. So what I am telling in real time, inside the switch, they will implement transistor. Your transistor, when you see real time, when you hold in real time practically, just a tip of your finger, a small like this, small shape. And what they will do, they will incorporate saturation and cutoff region and they will implement it to switch. If you make it is on, the tube light and the fan will run, the device will work. If you turn it to off, the device is going to off. On, off. Like this transistor will activate the switch. Understandable? You want to understand this equation? Everything is available in the graph. You should know that graph. Cutoff region, both are reverse bias. Saturation region, both the junctions are forward. Inactive region, emitter base junction is forward bias. Collector base junction is reverse bias. Understandable? Say sir. So my next topic is that is related on active region. In active region, the transistor will work as an amplifier. What is amplifier? What do you mean by amplifier? आप लोगों ने गाना नहीं सुना क्या? यो मिसिंग का गाना. Have you heard a song of yo missing? For तुम्हें better amplifier. Amplifier means now my voice is good. I can reach up to the last bench. I already said I want to reach up to 2 classes. This is somewhat bigger to somewhat distance. I use mic. In that mic, they will implement amplifier. Transistor can be used as an amplifier. Means it will boost, it will increase the strength of a signal. In my condition, voice is the signal. So transistor in active region can be used as an amplifier. What amplifier will do? It will increase the strength of a signal. In the mic, the signal what we are giving to the mic, voice will be increased so that it can reach to somewhat far distance. Clear? Says understandable? I hope it is understood. So my next topic is that